Hello, everyone. I wanted to explain some of the answers for the line graph practice worksheet that you did, seems like forever ago now. But if you handed it in, I'm going to get it back to you and put it in my grade book for practice. But let's just kind of take a look at this, and hopefully you can compare it with your answers and see what you might have done wrong or hopefully done right. So the first question was, um, what is the line graph about? Hopefully, if a graph has a good title, it will tell you exactly what it's about. It'll have information about the y-axis, which is the dependent variable, and the x-axis, which is the experimental variable. So in this situation, the line graph is about small town teens with cell phones. Okay, so it's talking about teenagers and how many of them have cell phones. The second one was at what age do teens have the greatest number of cell phones? Well, you look at the line graph and look at the highest number and go down here, and it's at 19. That's the highest it goes in this situation. What age do teens have the least number of cell phones? Well, look at the line again and look at the lowest point, and that would be 13-year-olds, which kind of makes sense. Number 4, how many cell phones do 15-year-olds have? And so you're going to look at 15 and you're going to go straight up and see where the line intersects, and it's 341. Now, this is one of the answers or one of the reasons why it's good that they have this data point, because it would have been hard for us to estimate and get the exact number, because we're looking at between 200 and 400. This would have been 300. That would have been 400. It would have been difficult for us to exactly guess the exact number. So that's one of the benefits of having the data point. So the answer is 341. Now 5 says approximately how many cell phones do 16-and-a-half-year-olds have? Well, 16-and-a-half is going to be right about there. You go up and see where it intersects, where the line intersects, and then come over to the y-axis. It could be a little bit above 500. I don't know that it's exactly 500. So that's why I put the little squiggly line, which means about 510. And once again, we have to estimate because we don't have the dot with the data label. So it's about 500, a little over 500. Now, some people got this wrong because they didn't read it closely enough. It says, what was the greatest number of cell phones at any age? Well, you already said that it was 19-year-olds that had the most cell phones. Go up and look at the data point, 642. What was the least number of cell phones? Well, you already said it was 13, and at 13-year-olds had about 229. So some people didn't give me the right answer because they didn't read it close enough. So make sure you're reading the question closely. All right, let's turn it over here. Okay, so I should have said about the graph instead of the experiment. Some people got confused and they were looking at the experiment that we did with the flour and the colored water. That's not really what I was talking about. So says, what is the experimental variable? What's being tested? Well, in this situation, it's the age that's being tested. We're testing to see, do 14-year-olds, 15-year-olds, 16-year-olds, 17-year-olds, 18-year-olds, 19-year-olds, 13-year-olds, how many cell phones do they have? So the answer should have been the age. Now, here's a little bit of a clue. Most of the time, the experimental variable, see how it's spelled with an X, is on the x-axis. So not all the time, but most of the time. Number 2, what's the dependent variable? What was being counted? Well, the number of teens with cell phones. The dependent variable is always going to be on the y-axis. There really isn't an exception to that I know of. So if you're looking for the dependent variable, look over here. Okay? Moving on. So what would a good problem question be? Well, look at the example on the wall. Some people wrote the stuff about the flour experiment. That was just an example, people. In this situation, the problem question would have been, how does age affect the number of teens with cell phones? The experimental variable always goes before the word affect, and the dependent variable always goes after. So that's one way to figure that out. We'll practice more with that. The next one, why is it helpful to have the dots with the numbers on the line? Well, so that the exact number is known. It's too hard to tell. Once again, when there's a big range of numbers, like from 200 to 400, it's hard to know that that little dot is exactly 273, or that that dot is 229, or that this dot is 590 and not exactly 600. So that was the benefit there, so that you could know the exact number. And then these were kind of opinions, the next one. These are some answers that I got that I thought made sense. Number 5, why do you think 18-year-olds have fewer cell phones? Well, maybe it's because their parents stopped paying for their phones, their clothes, whatever. You know, when you're 18, you're legally an adult. Maybe people are busy with jobs or college. That could be a factor. Number 6, what would your prediction be for how many cell phones? Let me read that. What would your prediction be for how many 20-year-olds would have cell phones and why? Explain your thinking using complete sentences. Most people predicted that 20-year-olds were going to have more cell phones than 19-year-olds, and that this number would continue to climb. And some of the reasons that were given was because maybe 20-year-olds are going to have a decent job and you can afford a phone on their own. Maybe their family's going to pay for them to have a phone because they might be in college and they need to stay in touch. So anyway, those are some of the answers that I got. I just like to see what your thinking is. And so I want you to compare this to what you had on your worksheet. And if you've got any questions, let me know.